In this last part of the video, we're going to talk about examples 8 to 12. So the first thing we remember at the very beginning of the lesson is that we learned that if we have cosine and arc cosine together, that basically those cancel each other out. So the value of this first one is just pi. Unfortunately, we do not have that relationship on the rest of them. So we're either going to have to start by finding the exact value, or we're going to have to start by finding the angle measure. So let's take a look at the tangent of pi over 4. So I'm going to go to pi over 4. And I remember that tangent is the sine divided by the cosine. So really what I have at pi over 4, I'm going to do some scratch work, is square root of 2 over 2 divided by square root of 2 over 2, which is 1. So I'm going to substitute that 1 in for this. So I've got the cosine inverse of 1. Well, really what I'm looking for there is the angle measure. So my angle measure, remember cosine is valid in quadrants 1 and 2 only. So I'm going to go to quadrants 1 and 2, and a cosine is the x value, and I'm looking for where the x is equal to 1. Well, I see the x equal to 1 right here. Let's see, do I have an x value equal to 1 anywhere else? Doesn't look like it. And remember that we don't start with 2 pi, we always start with radian measure 0. So we're just going to use, we know that this value is 0. Oh, I meant to erase, not to scribble. Okay, looking at the next one, it says that the cosine of pi over 6, so I'm finding the exact value. Pi over 6 is right here. Cosine is the x value. So I'm going to say we want the arc sine of square root of 3 over 2. All right, so that means now that I need to, when I see arc, I know I'm finding an angle measure. And arc sine is only valid in 1 and 4, okay? And we know that we're looking for the y value because it's a y value function, or sine is the y value. So I'm looking for a y value of square root of 3 over 2. Okay, there it is. So my radian measure that I'm looking for here is pi over 3. Now you'll notice that the next one is the opposite. They want me to find the angle measure first and then evaluate. So I'm looking for where we know that cosine is valid in quadrants 1 and 2. We know that the cosine is the x value. So I'm looking for where all the x values are equal to 1/2. Okay, so I'm looking for 1/2 as my x value. There it is right there. So it's at pi over 3. And now I want to evaluate the tangent at pi over 3. Remember, tangent is sine divided by cosine. So the sine is the y value. I get square root of 3 over 2. Cosine is the x value, so divide by 1/2. And then we've seen this a bunch of times. The 2's cancel. So I'm just left with square root of 3 over 1, or just square root of 3. Let's try this again, a little bit trickier on the next one. Okay, so again, my arc tangent's on the inside, so I know I have to find the angle measure for this. Arctangent is valid in quadrants 1 and 4. Unfortunately, I need to find the sine divided by the cosine where it's equal to negative square root of 3. Well, we did this the other day where we know that all of the values have a square root of 3, a square root of 2, or a 1 in the top. So if I rewrote the square root of 3, I'd really get negative square root of 3 over 1. We also know that they're all divided by 2, so I'm recreating the coordinates. So I'm actually looking for the coordinate on this one of 1/2 negative square root of 3 over 2. So 1/2, ooh, that's positive. Looking for 1/2, there it is, 1/2 negative square root of 3 over 2, and we know that we're using negative pi over 3 for this. So we're looking for the sine of negative pi over 3. So I'm here at negative pi over 3. I know the sine is the y coordinate. So I'm doing square root of 3 over 2. Make sure that you do your summary and it answers your essential question.